This is a video from my Calculus 1 Exam 2 review. The directions say to find the derivative, simplify your answer where appropriate. Let's take a look at problem number 6. So in problem 6, we have y equals x times the inverse cosine of x. dy dx is equal to, by the product rule, I'm going to write the first function and then take the derivative of the second function with respect to x, which is -1 over the square root of 1 minus x squared. I'm going to write the second function, which is arc cosine of x, and then take the derivative of the first function, which is 1. So I get -x over the square root of 1 minus x squared plus arc cosine of x divided by 1. So I'm going to take the second term and multiply the numerator and denominator by the square root of 1 minus x squared. So therefore, dy dx is equal to -x over the square root of 1 minus x squared plus the inverse cosine or arc cosine of x times the square root of 1 minus x squared divided by the square root of 1 minus x squared. So writing this as a single fraction, we can say dy dx is -x plus arc cosine of x square root of 1 minus x squared divided by the square root of 1 minus x squared. And that's how you do problem number 6. Let's take a look at problem number 7. On problem number 7, we have y equals t to the 4th minus 1 divided by t to the 4th plus 1. Using the quotient rule, we can say y prime is the bottom function, which is t to the 4th plus 1, times the derivative of the top function, which is 4t cubed. Minus, then I'm going to write the top function, which is t to the 4th minus 1, times the derivative of the bottom function, which is 4t cubed. And I'm going to take that answer and I'm going to divide by t to the 4th plus 1 raised to the second power. And so this is one where we need to simplify for sure. And so to simplify this, I'm going to factor out a 4t cubed in the numerator. So if I take out a 4t cubed from the numerator, in parentheses, I'm going to get t to the 4th plus 1 minus t to the 4th minus 1. And I'm going to divide by t to the 4th plus 1 raised to the second power. Now, distributing that negative inside, right, within that bracket, right, we get the following. We get 4t cubed times the quantity t to the 4th plus 1, right, that's the first piece, minus t to the 4th plus 1, divided by, and in the denominator, we have t to the 4th plus 1 raised to the second. But I can cancel out these t to the 4ths right there. And so this is 4t cubed times 2 divided by t to the 4th plus 1 raised to the second. So therefore, y prime is 8t cubed divided by t to the fourth plus 1 to the second. And that's how you do problem number 7. Let's take a look at problem number 8. On problem number 8, we have x e to the y equals y sine of x. So we need to do this problem by implicit differentiation. So what I'm going to do is I'm going to differentiate both sides with respect to x. So the derivative of x e to the y with respect to x is equal to the derivative of y sine x with respect to x. Okay. Now, let's apply the product rule. So let's write the first function, x, and I'm going to differentiate the second function with respect to x. In other words, this is x times e to the y times dy dx. I'm going to go plus e to the y, and then I'm going to multiply by 1, right? Because that's the derivative of x. That's on the left side. On the right side, I'm going to write down the y. That's the first function. The derivative of sine x with respect to x is cosine of x. And I'm going to go plus. Then I'm going to write sine of x. That's the second function. And then I'm going to multiply by the derivative of the first function, which is dy dx. Okay, so I'm going to combine the x e to the y dy dx and the sine x dy dx. I want those two terms, in other words, on one side of the equation. So I'm going to say x e to the y dy dx. And then what I want to do is I want to subtract this term to subtract it on both sides. And when I do that, I get minus sine of x dy dx. So that's on the left side. On the right side, we get y cosine of x, and then I want this e to the y term to be on the right side of the equation. And to do that, I'm going to subtract off e to the y. So I get that. So dy dx, if I factor that out of the left side, inside the brackets, I get x e to the y minus sine of x. And then that's on the left side. On the right side, we get y cosine of x minus e to the y. I wish you all had math calculus 3, because this problem is so much easier to do using calculus 3 methods. Now, having said that, let's solve for dy dx. dy dx is equal to, so I get y cosine x minus e to the y. That's the numerator. The denominator will be x e to the y minus sine x. And that right there is how you do problem number 8. And that'll conclude this video where we worked problems 6, 7, and 8. Thank you.